Hello, hi. Welcome to my talk. It's very loud. There we go. Better? Still pretty loud? So my talk is called Untitled. Thank you all for coming here. No, just kidding. It's called Breaking the Rules, Monitoring Your Node Application. And my name is Ron. I am from a company called Upbeat, and we do monitoring. And this talk sort of came out of some of the recent work we've been doing with Node, and specifically monitoring in Node. So it's going to talk about how you can do monitoring in Node in sort of a general way. Hopefully it's going to be interesting, and hopefully we're going to be breaking some of the rules a bit. So the goal here is I want to show you how you can get out-of-the-box monitoring for your web application in Node. And so out-of-the-box monitoring for me means that I can see how long my endpoints are taking to respond, but I can also see how long time I'm spending in each endpoint talking to MongoDB, for example, how long time it takes to talk to Redis, how long time I'm spending rendering templates, etc. And I want this per endpoint. But further than that, I want it to be out of the box so that I don't have to go and change my application very much to get this monitoring. So I want it to work in a way that I can just require some module, and that basically gives me out-of-the-box monitoring. So how do you do that? So first, I will introduce a bunch of small little things, primitives. So this is a trace bookkeeper. It's very, very simple. You can call start and end on a trace bookkeeper, and basically it will create a new trace if it doesn't already have one with this name that you gave it, and then call start on it, and then you can end the trace with a specific name. So that's pretty simple. I want to keep one of these trace bookkeepers around for each request to my application. Trace looks like this. So when you do monitoring and a lot of stuff goes on at the same time, how do you measure time spent in an application? That can be kind of tricky. So let's say you have two Mongo queries going on at the same time. It doesn't really make sense to sort of add the time up that each one of them spent. So the semantics around how you actually measure time when stuff happens concurrently is kind of interesting. And what this trace thing will do is that, let's say you have two Mongo queries that start approximately at the same time, but one ends way later than the other one. Then with this trace primitive here, we're going to count the time from the first one started till the last one ended. What it also does is it can sort of measure consecutive traces. So if you start a Mongo query and then end it, it'll take that time and sum it with the next Mongo query you're doing. So if you have Mongo queries that are not overlapping, it will sum the time for each Mongo query together. Okay, so that was some low-level stuff. Sorry, that was some primitives. I think one more thing to notice here is that I'm using the high-resolution timer. And if you're doing timing, sort of monitoring like this, you should be using the high-resolution timer, because it's much more low level than breaking out dates and starting to compare them. Yeah. Okay, so let's start breaking some rules. First, we want to hook into HTTP server add listener, and that's part of the reason why we would do that is part of the idea that it should be something that works out of the box. So what I'm actually going to do is I'm going to monkey patch the add listener method on HTTP server. And there's a lot of stuff going on here, but what you actually need to sort of see is that we will call on request instead of the original callback, and we'll start a new trace bookkeeper for this particular request. We'll set it on the request, and once the request is finished, we extract the route name from the request, and we call this method called request finished. So this obviously requires that you're building an Express application, but you can do the same thing for most of the other frameworks out there. Yes. Okay, now that was sort of our hook into the request response cycle. Now let's actually start measuring some code. So this is an example of how you could be calling Redis, talking to Redis. This could happen anywhere in your application. And it's pretty standard. So you try to get a key from Redis, and when you get it, you can log it out to the console. So how would we measure the time it actually took to get this key from Redis? This is one way to do it. You can see that I'm using something called trace code here, and I gave trace code this name that I'm passing in. This time it's just Redis get. Sort of indicates what I'm currently trying to measure. And you see that trace code will return a function that then wraps the original callback. So when I call trace code, it'll start the timer, and then when the callback is called, I'll stop the timer and then call the original callback. You could monkey patch the Redis library if you wanted to get this out of the box. I'm going to leave that as an exercise, but it's quite simple to do. And you can see what trace code looks like here. So that's also quite simple. We'll call start on the current on the bookkeeper for the current request when trace code is called, and then we return this function that will wrap the original callback and call end on the bookkeeper for this name. So you might think this actually doesn't work because there's something missing here, and then you would be right. The request is missing. So what's going on here is we have a request that comes in through our HTTP server, and we want to measure some code that happens somewhere else in my application and connect it to this request, because I want per request or per endpoint measurements. So how do you do that? That's pretty difficult, because a lot of stuff can go on in between the request to the web server and you actually measuring some code somewhere in your application. So connecting measurements to a request is not that simple. You have event loop ticks, and you have a lot of requests going on at the same time. So there was this wonderful API called create async listener, and the quote there is from the documentation. And what this does is it basically gives us a hook into the event loop. So that means we get a callback just before anything is put on the event loop, and we get a callback just after something is about to start that was on the event loop. And just before we put something on the event loop, we get the option to store some data that will then be restored when that thing that we're about to put on the event loop actually runs. And using this, you can actually pass down the request from where the request from where we hook into the HTTP server all the way down to where we want to trace our code. So it's like a primitive to actually allow us to pass context between async ticks in Node. And that's wonderful. That's exactly what we need. Unfortunately, it only lived in Node for a very, very short period of time. That's really unfortunate. So how do we solve this? We do some monkey patching. So basically what you can do is you can monkey patch every single time or in every single scenario that something gets put on the event loop and obtain the same functionality. And that's pretty complicated. There are some libraries out there that have tried to do it. So the most popular one is the async listener. There's also some stuff going on in the Angular world with Zone.js. And there's something called async wrap, and there's a working group that is working with this, which is the most promising of the sort of native primitives right now. It's not in yet, but hopefully it'll be that soon, so we don't have to monkey patch so badly. But so for right now, you actually have to monkey patch. So there's this library called async state that Thomas wrote. Thomas is right here. And it's based on async listener. So it takes this pretty convoluted interface that's called create async listener, and basically allows you to save some state anywhere in your code, and all the stuff that you put on the event loop will then have this state available for you. So it's a much more intuitive interface, and it looks like this. So you require async state. You basically set something on the async state, and then it gets sort of frozen. So when I put something on the event loop, it's going to take whatever is in whatever is currently in state in async state and make that available when the thing runs that I've put on the event loop. So this will print foo and then bar, which is a little bit counterintuitive if you look at the execution order here. But that's sort of a simplified or a much easier interface for us to use to pass data between execution contexts. So let's go back to our beautifully wrapped HTTP server. So the new thing here is that when I have a new request, I actually put the request in my async state, which means that all the stuff, all the things that I put on the event loop now will have access to the request, and which is great. That's exactly what we need. So that means that in my trace code helper, I can just pull out the request and start doing my measurements on the request. So that's quite useful. And all we need to do now is actually to, when our request is finished, we need to take all the measurements that we made for this request and sort of put it in a global somewhere that we can access. So that's what request finish does. This is what that looks like. It's very, very simple. Just sort of take the stuff that is in Bookkeeper and put it in request stats. Not going to spend too much time on that. And then finally, we can expose it as an endpoint in my Express application. So that's what this thing does. You see at the bottom here, I have /stats. And calling that, I will get a nice JSON that actually shows what the time has been spent on. So what I'm doing here is I go over all the stuff that I have in my request stats and average things out. So I can see on average how much time is being spent in Redis, how much time is being spent in Ongo, etc. And so it looks like this, basically. Expose this endpoint. You can see how many requests are being made to each endpoint, and you can see how many Redis gets, how much time I on average spend on Redis get, how much time I spend on LRange, how much time I spend rendering the index view, etc. Yeah, so that was sort of a whirlwind of how you can patch up your Node application to get performance out of the box. And there's a lot of complications involved here. So at Upbeat, we've been working on this, and if you don't want to spend all that time doing it yourself, you can check out Upbeat. It looks like this. That's pretty much it, actually. That was 12 minutes.